Agentic AI changes the economics of software. Every reasoning step, tool call, retry, and branch can affect both cost and quality. In this course, you'll learn how to govern those dimensions together with confidence. We'll build the course step by step. First, we'll connect Agentic AI to FinOps principles. Then we'll unpack cost, quality, observability, and optimization. Finally, we'll turn those practices into governance, automation, and an operating model you can apply in real environments. This course follows a maturity journey, not a collection of isolated tactics. We start by understanding what makes Agentic AI different, because workload behavior shapes every governance decision. From there, we model and measure cost, quality, reliability, and value, so decisions are based on evidence instead of guesses. Next comes observability, because you cannot optimize what you cannot trace or allocate. Then we improve efficiency through routing, prompts, context management, caching, batching, and design choices. Finally, governance turns those improvements into repeatable operating practices, with feedback that keeps measurement and optimization improving over time. Use this course deliberately. If you're newer to FinOps or AI systems, follow the full path and build the foundation first. If you're intermediate, stay with the sequence, but go deeper where your role matters most: modeling, observability, optimization, or governance. If you're advanced, treat the material as a framework and reference, while still checking the basics so everyone shares the same language. As you learn, connect each concept to a real AI workflow. Track cost drivers, quality risks, and controls. After each topic, ask, what should we measure, automate, or govern next? Traditional cloud applications often resemble an assembly line. Known inputs, fixed steps, and scaling you can forecast with reasonable confidence. Agentic AI is more like an expedition. The system chooses paths, calls tools, consults memory, plans, retries, and sometimes loops before reaching an answer. That flexibility creates value, but it also makes cost less predictable and quality harder to separate from spend. FinOps for agents starts with this shift. Govern not just infrastructure usage, but the decisions and behaviors that generate that usage. At the execution level, the difference becomes clear. In a traditional application, a request usually triggers known logic, reads or writes data, and returns a response. In an agentic workflow, the system may interpret the goal, plan steps, gather context, use tools, reflect, retry, and then answer or act. Two identical requests can take different paths, consume different tokens, and invoke different services. That variability is the FinOps challenge. The unit of work is no longer a single request or API call. It is the full reasoning workflow. An agent is not just one model call. It is a workflow of connected services. The orchestrator decides what happens next, then may call an LLM, query memory, retrieve documents, invoke an API, apply guardrails, or send results to evaluation. Each handoff can add tokens, compute, network time, and operational risk. Loops make this especially important, because one user request can become many internal actions. FinOps therefore has to trace the full path: what ran, how often, how long it took, what it cost, and where quality failed. Token pricing is only the most visible part of agent cost. In production, many steps can meter spend: retrieval, embeddings, vector database reads, tool calls, logging, evaluations, retries, fallbacks, and sometimes human review. That means the cheapest model is not always the cheapest system. If it needs longer prompts, makes more tool calls, or fails often enough to trigger retries, total cost can climb quickly. When you estimate agent economics, model the whole workflow. Count what happens before the answer, during the answer, and after the answer is evaluated or stored. Traditional FinOps remains the foundation. We still care about utilization, commitments, storage, network spend, auto-scaling, allocation, forecasting, and governance. FinOps does not replace that discipline. It extends it into a less predictable execution layer. Costs now depend on prompt length, token volume, model choice, routing, retrieval, tools, retries, fallbacks, and evaluation runs. Optimization is no longer only about cheaper infrastructure. It is about choosing the right model and workflow for the required quality, safety, latency, and business outcome. Forecasting also changes. Traditional cloud spend is often tied to resources you can count in advance. Agentic AI depends more heavily on workflow behavior. A simple Q&A may mostly consume tokens. A research workflow adds retrieval, longer context, and more output. A multi-tool agent can branch call systems, retry, evaluate, or fall back to a larger model. So two requests that look identical to a user can have very different backend costs. Forecasting needs to track cost per interaction, completed task, successful outcome, agent, tenant, and team. The main risk is amplification. A small task can turn into many paid operations when an agent plans, retrieves context, calls tools, evaluates results, retries failures, or escalates to stronger models. Each branch adds cost, and some branches feed back into the process. That can increase latency, create more failure points, and make spend harder to control. The answer is to govern the workflow, not just the model. Set budgets, retry limits, stop conditions, model routing policies, and observability so autonomy stays useful but bounded. Cost optimization cannot be separated from quality. If you cut spend by removing context, choosing a weaker model, or skipping evaluation, you may create cheap answers that fail the business need. But sending every task through the largest model, deep retrieval, and human review can be wasteful. A better pattern is routing. Simple customer questions get fast, lower cost handling, while escalations, legal, or financial cases receive stronger checks and auditability. Agentic FinOps governs both dimensions together, the best acceptable outcome at the right cost. Observability is not just logging. In Agentic FinOps, it is the control surface. Each request needs a trace that follows the agent's plan, model calls, prompt size, retrieval, memory access, tool use, retries, evaluation, and final outcome. That trace should also carry cost, tokens, latency, model choice, quality scores, and business tags. Once those signals are connected, teams can allocate spend, debug failures, enforce policy, forecast demand, and detect anomalies. The governing question is simple. Can we reconstruct what happened, what it cost, and whether it was worth it? Before agentic workflows scale, they need guardrails. Small design gaps can turn into runaway cost, poor answers, or unsafe actions. Start with practical limits: budgets, reasoning steps, tool calls, retries, context size, and retrieval volume. Then define which models and tools are allowed for each use case. Add quality gates before important responses or actions, and anomaly alerts for spikes in cost, latency, or failures. Finally, decide fallback rules. When to use a stronger model, stop the workflow, or involve a human. Governance should feel like a safety system, not a brake on innovation. You've built the foundation. Agentic AI costs come from complete workflows, not isolated model calls. Planning, tools, retrieval, memory, retries, evaluation, and infrastructure all shape spend and outcomes. Your next step is to map one real workflow, identify uncontrolled cost drivers, and check whether observability connects cost to successful tasks. Next, we connect this mindset to core FinOps principles.